Hi, third years. This is your lesson for today. It's on the topic of activity. If I write anything on the whiteboard here, you need to copy this into your red jotter neatly. Everything that I write on the board must go into your red jotter, and do it very neatly, please. Following this lesson, there is an assignment. The assignment has a number of things for you to do. Some of these things you can answer straight away in a Google Doc because it's some writing based on some short video clips that I'm going to post up. That'll also be in the assignment. There are also some questions for you to do, some problem questions for you to do in your green jotter. And that also needs to be submitted, and you'll be taking photos of pages in your green jotter and submitting them with the Google document that I've already mentioned. So that's three things here you've got to do is copy all of these notes that are coming up now in this lesson on the whiteboard into your red jotter. Then move on to the assignment. The assignment has two parts, some written answers to questions following a couple of videos into a Google document, and then some problems on activity, which will be done in your green jotter. Take photos and submit that as well. Okay, so what does the word activity mean? Sometimes we use the word activity. Sometimes we will use the word radio activity. And radioactivity, or more properly, activity, means the number of radioactive decays in 1 second. So imagine you've got a lump of radioactive material. And as we've mentioned already, you can get radioactive material like a piece of granite, for instance, out of the ground. And we've got a lump of granite sitting on the desk. And then next to the desk, we will have our GM, Geiger-Müller tube, and the Geiger-Müller tube will be connected to a thing called a counter. So this is granite, for instance, could be some other radioactive material, and you've already seen some radioactive samples. You'll see some in the videos as well. They're in little tiny metal cylinders with a spike out the other end for holding, and they contain radioactive material. So you get your radioactive material here, whatever it is, you set it up at a distance from the Geiger-Müller tube. So that's your granite or other radioactive, there's that word active, which is the same as activity, other radioactive material. Your GM tube and your counter. And the counter will count the number of radioactive decays over a period of time. And you'll see this in a video afterwards. Okay, so the counter's just got a display on it. And you might have a stopwatch or a phone with a timer on it. And what you'll want to do is probably record how much radioactivity is being picked up by the GM tube. And you might want to do this for a minute or 2 minutes or something. And then you're going to have to do a little bit of maths and work out what the count rate is per second, not in 2 minutes or 3 minutes, but what is the count rate in a second. Now, activity is measured in units called becquerels. And you've already come across this because Becquerel was the man who did exactly this with the lump of radioactive rock that he had as a paperweight. So activity in units called becquerels. We're a bit rude. We write the word becquerel with a small b, but we can abbreviate that to capital BQ. Okay, so supposing we did, just very, very simply, supposing we took some readings and we just did this for 10 seconds, and supposing we had 20 readings or 20 radioactive decays, 20 decays in 10 seconds, then how do we work out the number of decays in 1 second? So we just take 20 and we divide by 10, and that would be the same as 2 decays every second. So you would say that the activity is equal to 2 becquerels. Okay, so what is a radioactive decay? We already know from a previous lesson it's when an atomic nucleus emits some radiation, and it could be alpha, could be beta, could be gamma. The GM tube can't tell the difference between them. It just, this material sends out a little bit of radiation that it emits. It's picked up by the GM tube, and the GM tube just triggers what's called an event, triggers a little event which displays on here. So what normally happens is that you'll have the GM tube connected to the counter. The counter has a loudspeaker, and some of you might be aware of this, that every time the tube detects a little bit of radioactive decay, the counter goes click. You might have this going on for 10 seconds and it would go click, 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 click. And it's not a regular thing. It's what's called random. And you'll see more of that in the video. Okay, so what's a radioactive decay? Which we've got there. A radioactive decay is when a nucleus of an atom emits radiation, and that could be alpha or, sorry, I've written that wrong, alpha, beta, or gamma. There's my alpha symbol written, there's my beta symbol written, and there's my gamma symbol written out. Okay, now the idea of doing some notes and making sure you get all these notes is to stop the video if necessary. Make sure you've got all this written down. I'll be rubbing this out in a minute, so you don't have to keep up with it and try and do it at exactly the same time as I'm doing it. You can stop it, you can rewind it. Some people have been having a bit of trouble with pausing and rewinding Google Meets, so there will be a YouTube version of this as well, exactly the same, whichever one works for you, either the Google Meet recording or the YouTube recording. Pause, stop, rewind, make sure you get everything here written in your red jotter. Okay, I'm just looking for, I need to pause now. Oh, there it is. I need to pause because I need to find my rubber. Okay, so there is actually a formula that lets you work this out, and the formula is A equals N divided by T, and there is a triangle for that, A, N, and T. Now, what do these three things mean? You can probably work it out. A stands for activity, and that's measured in becquerels. N will stand for the number of decays, and T stands for time in seconds. So previously I did that little example and I said we've got 20 decays in 10 seconds. 20 decays in 10 seconds. And so I could have done A is N over T, and it's 20 decays in 10 seconds. 20 divided by 10 is 2 becquerels. Okay. And what I will be doing is giving you some worked examples that follow our well-known TUP for now method. The only thing I haven't done here is I've done a formula, I've put in some numbers, got an answer, got some units, but I didn't set out a table, and I didn't do anything with prefixes, but I'll be going through that very, very shortly. You will need to make sure you've got all this. Some people are keeping these triangles and formulae in the back of their red jotter. Feel free to add that if you've already got some triangles stored away somewhere. Okay. Right, so I'm going to do a number of worked examples now. And again, these worked examples will go neatly copied into your red jotter. Number 1. So a GM tube detects 240 decays in a time of 10 seconds. What is the activity? So the TUP for now information. And just a reminder, T is a table. What information are we given? So we've got the number of decays. So we're going to put down N is equal to 240 decays. I'm going to put down T is 10 seconds. I'm going to put down A, which I don't know. And I'm going to use my triangle. This formula is actually given on the formula sheet as well. So you don't need to remember it, you can look it up. So I'm going to write down A is N divided by T, which is equal to 240 divided by 10, which is 24 becquerels. And that's pretty straightforward. We're starting off with some nice, easy stuff here. Right. So I'm going to do an example on each page. Pause, stop, copy down as appropriate. Worked example number 2. Okay, so pretty similar. You're given the number of decays, you're given a time. The number of radioactive decays recorded in an experiment is 20 decays. The recording time, excuse me, was 45 seconds. What was the activity. We're going to make our table. The number of decays is 20 decays. The time is 45 seconds, and we need to find the activity, and there's our table. Now remember, T, table, followed by P for prefixes. There are no prefixes in here, so we don't need to bother with the prefixes bit, and we'll just go straight for the formula. A is N divided by T, which is 20 divided by 45, which is equal to 0.44 becquerels. So 0.44 decays every second. 1 becquerel is 1 decay a second. This is less than that. So if you heard a Geiger counter doing 1 decay every second, it would go tick, tick, tick. Just like listening to a clock, it would be 1 click or tick every second. Now this is much less than that. It's less than half every second. So that's like 1 every 2 seconds. So you'd hear it go tick, 1, 2, tick, tick. And then it might go for a little bit longer, and you might not hear anything for a few seconds. And then you might get a couple in quick succession. So this is just an average figure, because radioactivity is random and you cannot predict when any one radioactive decay is going to take place. So you might hear tick, 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 tick. Tick, tick, and you'd stop the experiment, and it's the total number of ticks or clicks in the total time averaged out. Doesn't have to be nice and regular. Okay, so that's the second worked example. Example 3. So this time we've got 350 decays and we've got 3 minutes. And I'm sure some of you will be saying, oh yeah, I know what to do here. The activity is the number of decays per second, and this is in minutes. So we're going to make our table. I don't know what the activity is. I'm going to put down that the number of decays is 350 decays. I'm going to put the time equals 3 minutes. So there's my table. I've now got to do this thing called prefixes, which really means changing minutes into seconds. So you have to say, right, there's 60 seconds in a minute. So 3 minutes must be 180. 3 times 60 is 180 seconds. So now you can go ahead and we can do the formula. It's the same formula, obviously. A equals N divided by T. It's probably a good idea just to make sure you do this properly, set it out, use the formula every single time you do this, because in any sort of assessment, there's actually a mark for this, and there's a mark for putting in some numbers, and there's a mark for getting answers plus units. So you already know that this is worth 1 mark, and then we're going to gain an extra mark for doing this, and an extra mark for working that out correctly. And we need to give these numbers to what's called 3 significant figures. 1, 2, 3 significant figures. We have to do some rounding. Don't just write down the number that appears on your calculator that marches on and on and on. So number 3. Worked example number 4. Okay, so how long will it take for a source with activity 1.25 megabecquerels to have 6.5 times 10 to the power of 5 radioactive decays? Now, it's been a bit of a while since we've done all this sort of thing. You would need to remember that mega means million. So this is 1.25 million becquerels. You're not going to be told what mega is in any test. You've got to remember these. And we previously did a lot of examples with using different prefixes. This is a real prefix, and there are other prefixes. You'll remember them: kilo, milli, micro, these sort of things. And you've got to remember what the prefix means and be able to write it down in what's called scientific notation. And this is scientific notation. So not only do you need to remember what the prefix is, you need to remember how to enter these sort of numbers into your calculator. So you're going to have to do a bit of memory refresh on how to do this sort of thing. So what have we got? We're going to do TUP for now. We're going to write down the activity, which is 1.25 megabecquerels. We're going to write down the number of decays, 6.5 times. I think I need to change this actually I'm going to change that to 7. Sorry. I'm going to change that to 7. 6.5 times 10 to the power of 7 decays. That's my mistake. Apologies for that. And how long does that take? How long in time does that take? That I don't know. Okay. And I've got my triangle again. And it's usually a good idea to start with the formula that you get from the formula sheet, which is A is n divided by t. Now, we can't put in these numbers like mega into our calculator unless we do the prefixes bit. So you're going to have to change mega into the proper number, 1.25, and it's million times 10 to the power of 6 becquerels. Okay, so you must do that. So TUP for now table is done, prefixes is done, formula is done. We can now put the numbers in. So we just go for 1.25 times 10 to the power of 6 equals 6.5 times 10 to the power of 7, all divided by t. There's my A, there's my N, there's my T. Now we know that we can rearrange that to be that T is N divided by A. And the way we do that in maths is we do something called cross multiplication. The T goes up there and the A goes down there, and you cross multiply them. You cross things over and swap them over. So that gives me T is N divided by A, which is 6.5 times 10 to the power of 7. Just getting a bit mixed up with my T there, be careful. 6.5 times 10 to the power of 7 divided by 1.25 times 10 to the power of 6. Now, you're probably not going to be able to see this on my calculator, but just a reminder of calculator buttons. We would do 6.5 and then the times 10x button times 10 to the power of 7. And that's just a bit of reminder how to do that. And you probably can't see that there, but we're then going to divide by 1.25 times 10 to the power of 6. And then press the equals button. And that appears to give me a time of 52.0, just says 52 on my calculator, 52.0, three significant figures, 52.0 seconds. So there we go. Okay, and that's my worked examples done. 4 worked examples that you'll need to get copied into your red jotter with full working, full setting out. Remember, when you're doing these sort of division sums, you want this sort of thing on one line in your jotter. This goes underneath in another line. So we've actually got our jotter line would come along here, and you put this division line on the line in your jotter. Okay, don't scrunch it all up. So you're trying to get everything all squeezed up into one line. I'm just going to move that T up there a little bit so you can see it's out of the way. Okay, so that's the end of the worked examples. I'm going to stop the recording there. Make sure you get all that copied out into your red jotter. Okay, and I'll stop